Good morning. It's a pleasure to be with you this morning and talk about our experience that we are having for several years with our clients and move companies from sell-in to sell-out. I'll explain you in more details what we understand about sell-in and sell-out. So, I am the founder of NeoGrid, and for 16 years we are working to enable automatic decisions to our clients to synchronize the supply chain, but simultaneously reducing inventory levels and stockouts. And this is something very important because it's very easy to reduce stockouts if I increase inventory level. And it's very easy to reduce inventory levels, but increasing stockouts. So we want to do both simultaneously, and this is what we are reaching and improving the service level to our clients. This is our headquarters in Joinville, Brazil, and we also have offices in São Paulo, Porto Alegre, Brazil, an office in Chicago, UK, Amsterdam, and also Japan. Some of the retailers that we've been working around, you probably know most of the names here. Manufacturers, which are the suppliers for all the networking, we have also several brands. You probably know most of the brands here. One concept which is very important and I would like to cover with you this morning is about orthodoxy. Orthodoxy is everything we do. We don't know why we do, but we keep doing it. Actually, orthodoxies are related to technology constraints. For example, most of the business rules were created under a technology constraint. But once the constraint was removed, the business rule remained the same. It means when we didn't have technology, companies had to build their rules, even under pencil and paper. They had to build a business rules, and the company were surviving. We were surviving. But the problem is that when this constraint was removed, the business rules didn't change. And I'd like to give an example. Take, for example, the business rules in hotel. Why in hotel we have check-in at noon and check-out at noon? This is probably because before technology, when reservations were made with pencil and paper, they had to to build some rule how to manage reservations. They couldn't actually provide a better service. They couldn't say, well, if the customer will arrive at 8 or whatever, manage this kind of need of the client. So hotels build the rule, check-in is noon and check-out is noon. That was the technology constraint. The fact is that once that constraint were removed, and then the software engineers went to a big room with brown paper and they re-engineered the process, the business process. They redesigned everything, they re-engineered the process, but they did not re-engineer the business rules. It was given. Check-in is noon and check-out is noon. And everything that we hear about globalization, new hotels, the software is the same, the business rule is the same, and still, if you arrive in a hotel 8 o'clock in the morning, we'll hear that your reservation, your room is not ready, you have to wait actually until 2 o'clock and sometimes until 4 o'clock in the afternoon to get your room. This is no longer a problem of technology. This is an orthodoxy. You all know that technology could fix very easy this problem and get a reservation according to the client's need. So it's very easy to understand the orthodoxy in the other's business. But if you think about our business, our companies, our day-to-day, do we have orthodoxies in our companies? Yes, we do, and maybe much more than the example that I just gave to you. There's another concept that I'd like to cover with you. I talk about local optima and global optimum. So we learn to define our space and make this space, which is our space, we want the best. We want to make this our space our local optimum. But every time that we define a space and make this space the local optimum, we can generate undesirable effects outside this space. And to improve efficiency, if we say a company inside a supply chain or a department inside a company, these will be silos. So each silo will work for its local optimum. In matter of fact, the local optimum is like an air conditioner that cools in one side but heats in the other side. So we can say that therefore the global optimum is not the sum of many local optima. So if we try in our organization to improve each department and try to have each department in the organization the local optimum, we will not have the global optimum in the company. And same rule applies to the supply chain. Each company in the supply chain is working for its local optimum. And every time the company try to do this in order to have its local optimum, we will not get the global optimum for the chain. Let's talk about another concept: simple system and complex system. We have in our left system A, and on the right system B. System A, 7 circles. System B, 7 circles with arrows. Which is the most complex system? System A or System B? If we have to describe System A is simpler because it's very easy to describe. We'll say, well, it's 7 circles. And System B, we have to describe the circle and the arrows. But if you think in the concepts of physics, it's a little bit different. On physics, a system is simpler or complex depending on how many points I have to touch in order to impact the whole system. So in System A, we have to touch in 7 points to impact all the system, while on System B, if we touch in one single point, we impact all the system. And we call these degrees of freedom of a system. In System B, we have 1 degree of freedom, while on System A, we have 7 degrees of freedom. So the System B is a simple system, and System A is a complex system. So, how is this related to our companies? It's everything. So, if you are talking about supply chain, we have in the past, we had independent companies because the technology didn't allow companies to work together. So each company was working by itself with their own ERP, and then we had and we still have a complex system. Exactly in the way or in the example of the hotel, most of the companies, although we have new technology, but we have created and we have implemented the old business rules invented when we didn't have technology. So for a new technology, we must develop, we must invent new business rules. So we had a complex system in the past because we didn't have technology. But now we insist to have complex system, although we have technology which enables us to have a simple system. And this is all about our presentation. So we have a conflict in the supply chain. And the conflict is again the local optimum and the global optimum. So all the companies, we want to maximize profitability in all the companies in the supply chain. In order to do that, we must maximize individual short-term profitability, and we must maximize gains to the end market in the supply chain. But in order to maximize individual short-term profitability, what we have done, we are focusing on the next link. But to maximize gains to the end market, we must focus on the consumer. So when we focus on the next link, we are playing, we are in the power play. So if the manufacturer or retailer has a power, this is where companies is working, or companies are working with the best price or inventory. They are moving according with their power. And when we focus on the consumer, we'll have actually the win-win. All the companies in the supply chain will win. When we focus on the next link, we are in the sell-in. So sell-in is to make the sales to any other level or any other company into the supply chain. And sell-out means when we do the sales to the end consumer, because until the end consumer buys, nobody sold in the chain. So sell-in means, is to sell inside the supply chain, and sell-out means to sell to a end consumer. That's the big difference, sell-in and sell-out. Sell-out from the supply chain to the end consumer. So I have some considerations that I'd like to cover. Some rules or business rules that we have invented before technology, and what should be the rules that we could apply, that we could enable after the technology. So in the complex system, the companies didn't know what was going at the store level, at the consumer side. And they have to implement their own ERP. And what ERP have is the information about selling. On the ERP, they have the history on the past, number of units sold last year, last month, and that was the information they had to run a demand planning, to run S&OP, and how much the sales team should push to the next link. And this is the concept of selling. Once we have technology, we have the arrows, we have the integration, which allow us to understand the sellout. We are enabling a pull system. We understand the inventory in all the levels on the chain, and we are replenishing the actual demand, and also the plant will work according with the actual demand from the market. There is no need to check history, to check the past, because we have an information much better than the past information. We have the actual consumption. So when we had a complex system, we had to work with the local optima for each company, and they were trying actually to push the inventory to the lower level because they said, well, it's important to have inventory at the store. We never know if the supplier will provide me, or every time that I had to place an order, this order would take 30 days until have the replenishment. And actually, the manufacturer used to say, I want to have the lowest inventory in my plant warehouse, and I want to push the inventory to the stores. Now, once I have a simple system, the system, so every time that I push the inventory to the store, I am increasing the risk of stock out in another store. Even if I have inventory at the store, actually the retail will say, well, I have 90 days inventory here, and I want you, manufacturer, a 90-days term to pay because this is the inventory I am holding. So even that the manufacturer money is on this inventory, he cannot manage the inventory in order to get the best return of its own money. So now that we have information about all the stores, it's much better to hold the inventory upstream and replace this inventory as fast as possible to the stores in order to avoid stockouts in all the stores. So the inventory location in the complex system used to be on the stores, and in a simple system, it's much easier, it's much better. We can improve the return on inventory when we hold the inventory upstream as close as possible to the manufacturer, to the plant. In the complex system, we manufacturer or the manufacturer had to wait the order from the retailers, and the manufacturer didn't know what to do until he gets the order. So the order was initiative from the retailers. Now, in a simple system, once we have the integration with the retailers, We get information every day about sales and inventory. So the manufacturer doesn't have to wait an order until we start the production. They know exactly the everyday consumption, and the manufacturer can schedule his plan according with the daily consumption for each product. And we can also do the automated replenishment for all the levels. The trade marketing in a company had only information about selling, and any marketing campaigns they would know after some very complex analysis. With the integrated system, the trade marketing can monitor the sellout every day, and if they launch a campaign in a city or a TV program, wherever campaign it is, they can monitor the results of this trade marketing in the next day. As a orthodoxy, and maybe this is the most devastating effect in the complex system. Once we didn't know about the inventory at the store level, actually companies had only condition on the only way to pay commission to the salesperson was for the sell-in information. Every time they get an order from the next level, they would get a commission. So that commission was a commission to the push system. Actually, once, as we have told before, until then consumer buys, nobody sold. So the most important in a simple system is that the sales commission or all the salespeople who should be monitored or should be compensated according with the sellout information, but not with the sell-in. When we do and when we push the inventory to the next level, the devastating effect is that we are going to increase the inventory of the store with products that are not selling, with non-mover products, and if we have product stuck on the shelf, this product stuck on the shelf will avoid to have a new product that could be a fast runner. And this will impact on future sales in the organization. So we can and we enable companies to monitor the activity level on each store in a way that the non-moving products should be replaced with the fast mover products. In the same way, in a complex systems, companies, once they only had information about selling, they had to work about demand planning using history data. They have the S&OP to run sales and production meeting and define what they are going to produce next month, and this is produced to stock, regardless what is happening on the chain, regardless the level of inventory at the warehouse, at the plant warehouse, or somewhere else on the chain. The new concepts allow us to replenish inventory at all the levels, and production will start working. Instead of make to stock, production will start working with the concept make to availability, to make product available to be replenished according with the actual consumption. I'd like also to cover the metrics in the supply chain. Eli Goldratt said, "Tell me how you measure me, and I'll tell you how I will behave." When we are talking about the complex system, most of the companies, as orthodoxy, defined the local optima to measure each actor in the supply chain. And if we go deeper to an analysis, in most companies, different actors in the supply chain are being measured with conflicting metrics. The production manager is measured to reduce the cost of production, and he is measured to deliver the production, regardless if we are selling this product or not. The logistics manager are measured to reduce the cost of transportation, regardless if we have excess inventory or stock out in the other side. Sales manager are measured to sell in. On the other side, the buyers are measured to buy in a lower price, regardless the inventory they are building. And again, the logistic manager is measured by the transportation costs, and the store manager is measured to the sell out to the consumer. Most of the actors in a supply chain are measured by conflicting metrics. And I would say that the most important for this supply chain is generate cash. So how could we create a measurement, a metric that should align all the actors in the supply chain in order to generate cash? So we have evaluated which are the events that could get frustrated cash generation or impact in cash generation. If we lose sales, we will be, of course, impacting in cash generation. And if we have excess inventory, we are also impacting cash generation. So if you take the number of days on the stock out, and if we multiply by the daily throughput, the margin for each SKU during the stock out period, we will have a KPI that we are calling TVD, Throughput Value Day. And if we have excess inventory, the days that we have excess inventory, if we multiply by the cost of this SKU, we will have during this period what we call IVD, Inventory Value Day. If we want to see a graphic, let's say we have the green zone, yellow zone, and red zone, which is the safety level. So every time that, let's say the blue line is the inventory level, and every time that the inventory level reach the red zone, we start to count the TVD, number of days at risk of losing inventory, multiplied by the margin of each product every day. In this case, this area is the TVD and also this area here. Now, when we have excess inventory, then every day we have on excess is the cost of the SKU multiplied by this excess inventory, and then we have the IVD, Inventory Value Day. Of course, in our company or in all the companies in the supply chain, we want TVD to be 0 and IVD to be 0, which means we want the inventory levels floating on the yellow and green zone. So we have to work to bring TVD to 0 and IVD to 0. The beauty of these two KPIs, they are operating KPIs. They are not metric of performance. The performance indicator are KPIs that you measure at the end of the month, and then you will see how was the performance on the past month or the past week. The TVD, IVD are operational indicators. They can tell you what I have to do now to avoid stock out, what I have to do now to avoid excess inventory. And NeoGrid also provides several algorithms, but it's important to monitor the inventory levels. So in this particular algorithm, if we have too much green, the algorithm will automatically change the inventory levels, what we call the norm, to a lower level, which means we can also generate IVD, not because I have acquired more product, but because I have reduced it, the level of the norm. In this example, we brought the inventory levels here on the yellow. Here we have some red, but we didn't reach the stock out. And again, the system automatically drop once again the inventory level, generating IVD. And of course, every time that we are generating IVD, the system is not placing an order to the supplier. This is an example how we can dynamically change inventory levels. And of course, if we have too much red, the system will automatically increase the inventory levels for in the example, the green zone. So I have some example from our clients that you can see, for example, the TVD in a fashion companies for a category, where you can see that the TVD, they were acting day after day, where or which store and SKUs we have generating TVD, and that's the priority for the replenishment during the season. So we could, in this example, reach TVD almost zero. And at the same time, same company, same period, same category, we could also reduce the excess inventory. So this is the beauty of the system. This is not a performance indicator. This is an operational indicator showing to the managers every day what they have to do in order to reduce excess inventory and reduce the stockouts in all the organizations, in all the levels. So now, once we have the TVD, IVD, we can have all the actors in the supply chain working according with the new KPI. So the sales manager in a company, they will be working to replenish their products to the next level according with the TVD, and the clients or the distribution center with the highest TVD will have the priority to get the product. So in this way, every actor in the organization will be working to reduce excess inventory, to reduce stockouts, and of course make the products available to the consumer. So at this point, we will solve the conflict that we said before. So instead of the power play sell-in, we move our company from sell-in to sell-out, and we have to break the orthodoxies, changing the company rules. So the manufacturer will focus on the consumer, and the retailer will share the sellout data in order to allow the manufacturer focus on the consumer. So then we'll have all the actors aligned with one single KPI, or two KPIs, which are TVD and IVD. In all the levels, all the actors, they are aligned with the same KPI, and they all are contributing for the cash generation. So this is another example how to see it. So the store manager, he is measured by the IVD. Every day the store manager should have or does have a report about all the SKU on the store generating IVD. And what he has to do, he must get rid of excess inventory or returning excess inventory to the distribution center or making a promotion on these SKUs at the store. The manager at the distribution center is measured according with the TVD generating at the store's level, which means he distribution manager must be sure that the stores are not generating TVD. And again, from the plant warehouse, he cannot accept products that are generating IVD to the distribution center, and the plant warehouse are being measured that they cannot allow TVD to be generated at the retail distribution center. And in the same way, the plant, the production, is monitored according the TVD generated at the plant warehouse. They cannot allow, or they must have a flexible production, and there are many rules in the lean system, but the lean system will be monitored with the TVD generated at the plant warehouse. So these are other concepts and the way how we can align the KPIs all the way all the actors are measured in an organization. So if we align all the actors in the company or in the supply chain, we doesn't have to focus only on the next link and trying to sell in to push the product for the next level, but we will focus on the consumer, we'll sell out, we'll maximize individual short-term profitability, but we will also maximize gains to the end market and, of course, maximize profitability for all the parties in the supply chain. From the clients that we have been implementing the system, we have reached, I would say, on average, reduction on excess inventory by 30%, and also out of stock reduction for about also 30%. This is an example, and we have not examples, but real case in large organizations, not only in Brazil, but also in other countries in Europe or US. So, in conclusion of my presentation, the most important is releasing organization from their orthodoxies and this is the real challenge. So releasing organization from their orthodoxies is the real challenge. Thank you very much. Thank you all. So now we are ready for questions, and of course, I'll answer. Thank you.